Okay, in this video we will talk about the determinant of 3 by 3 matrices. So first of all we will consider a 3 by 3 matrix with the general entries A11, A12, A13 up to so on. And then the determinant of this matrix can be written as so first of all the determinant can be expanded along any row or any column. I mean to say you can choose any row. For example, you can choose this row, or you can choose this row, or you can choose this row. You can choose any row or any column, column 1 or column 2 or column 3, along which you have to expand the determinant. Okay, so I am going to expand the determinant along the first row. You can expand it along the second row or the third row or any column. So determinant along the first row is, so first of all you have to write the first term along the first row. Since look at the indices of the first term, it is 1 and 1. If you add the indices 1 plus 1, you will get 2, which is even number. So for the even number you will write plus. Okay, so I will write plus because the indices, the sum of the indices is even number. So the next term is A12. If you add the indices 1 and 2, you will get odd number. So for the odd number you will write minus 1 2. So index of the third entry of this first row is 1 3. If you add 1 3, you will get 4, which is even. So you will write plus A13. Okay, so what is the second component of this first term? So this is A11. So if you cancel this column and this row, you will get this thing. So here I will write the determinant of this submatrix. How? Let's look. A22, A33, you can check. A22, A33, then minus A23, A32, you can check here. Now come to the second position. If I cancel this, because the second position is this, so we have to cancel the row and the column in which this entry is lying. I mean, I have to cancel this row and this column. What I left with this and this matrix. So I have to write the determinant formed by this matrix A21, A33 and A31, A23. Okay, so I have written A23, A21, A33, you can check here, and minus A23, A31, you can check here. Now the next term is A13. I will cancel the row and the column corresponding to this entry. So what I have left with this submatrix. So I will write the determinant of this matrix, and you can check I have written the determinant of that submatrix. So this is the determinant of the matrix A, which is 3 by 3. Okay, look at an example. You have an example to calculate the determinant of this matrix. Here is the solution. First of all, you will write I will expand the determinant along the first row again. So for the first row I will write the first entry, then the second entry with negative and the last entry with positive. For the first entry, I will write the determinant of this. So I have written down. For the second entry, I will write the determinant of this submatrix. Okay, the determinant of this submatrix is this. I have written down, you can check. And for the last entry, the determinant of this submatrix. The determinant of this submatrix is this, you can check. Now if I do calculations, I will get the determinant is equal to -5. You can check the calculations. Look at another example. You have to calculate the determinant of this matrix. Since in the beginning I told you that you can calculate the determinant of a matrix along any row or along any column. Whenever you are going to calculate the determinant, you will look at the row or the column in which there are more zeros. If you will look at that row or column, then you will avoid a lot of calculations. Since you can check that in the second row there are more zeros, so I will expand the determinant along the second row because it has 2 zeros and only 1 entry to avoid the calculations. Since this entry is named as A21, okay, so if I add the indices of this entry, the indices of this entry is 2 plus 1, which is 3, which is odd number. So along this entry I will write minus, so that's why I will write -0. And this entry is A22, whose indices are 2, 2. If I add 2 plus 2, which is 4, which is even number, so that's why I will write +5. So I have written down +5, and this entry is A23. If I add 2, 3, which is 5, so which is odd number, so I will write -0. So I have written -0 plus 5 -0. You can check. So look at this -0. This is the 0. I will skip this column and this row. What is the submatrix? 2, 7, 1, 3. So if I write the determinant of 2, 7 and 1, 3, this submatrix, I will get this. You can check. So for the second term, 5, if I skip this row and this column and this row, I will end up with the matrix formed by these numbers. You can check. Okay, so if I write the determinant of this matrix, which is -1 times 3, I mean this minus this. So if I write these terms, I will get this. And for the last term, if I skip this row and this column because this is 0, I will end up with this matrix. And if I write the determinant of this matrix, I will get this, which is very easy. Now if I do the calculations, I will get the determinant is equal to 125, and this is the answer. So similarly you can do expand determinants along any row or along any matrix, along any column. You will get the determinant. So the good thing is that expand the determinant along any row or along any column, you will end up with the same result. For example, I have calculated the determinant of this matrix along this row. you can calculate along this row, or you can calculate along this row, or you can calculate along this column or any column, you will end up with the same answer, which is 125. So this is very good exercise to check that if you calculate the determinant along any row, so calculate the determinant along any other row or column. Let's check that you are getting 125 or the different number. This is an exercise for you.